Welcome again, CM400C, week 1, lecture presentation number 3. Today we're going to learn about mobile app anatomy and types of mobile apps. So very exciting stuff. Here we go. All right, so let's begin with a review from the previous lecture. So remember we talked about the landscape of mobile app development and design. There's always 3 app goals. So solve a problem. You always want to captivate your user, and you want to make sure that you're always connecting your users, people to people and people to places. The 5 W's, right? Why are you building this app? What does your app do? What is the core feature? Who is your target audience? Who are your users? Where will your users use your application? And when will they use the application? And then you always want to keep in mind that in design and development, it's all about the 3 E's. Easy, entertaining, and you want them to be able to execute a task. All right, so let's dive in to mobile app anatomy. So these are the 3 parts I'm going to go over today. The user interface, which most oftentimes I'll refer to as the UI, logic, and data. So parts of the UI, right? The user interface. This is the part of the app that the user sees and interacts with by touch. It includes buttons, text, fields, and lists. The entire touchscreen interface is known as the UI. The user interface has attributes that describe its characteristics, such as height, width, and color. Let's look at a really familiar UI to probably most of us here. What do we have at the top? It looks like we have our status bar. Remember the difference between tab bar and toolbar and all those. The toolbar allows the user to perform easy tasks by simply clicking on a button. The 2 buttons on the left and right hand side serve as navigation models. Which navigation model is this? And remember last time we talked about the sliding cards. So you can see here on the right app screenshot that it has a sliding cards navigation. And then we also have in the Facebook app table view navigation as indicated on the right screenshot there of the Facebook app. And then there's logic. This is the code required to perform actions when a user interface object is touched or any other processing takes place automatically. Whenever an app does something, right, it requires code to execute a set of instructions. In other words, core logic is what the app does. The part of the app that performs a web search goes out to the internet to add text and retrieve weather or local news is all part of that logic. The IB outlet that refers to an interface builder outlet. This helps to connect an instance variable to a graphical element. In this case, my pause button, right, is an instance of the UI button class. And a button intercepts touch events and sends an action message to a target object when tapped. Right. So if we look at the code or the logic here, I have an IB outlet and it's called the pause button, and I have an IB action associated with if they press that pause button. So it pauses the audio player and it invalidates the timer. So just a little bit of code right there for you guys. And then there's data. Data is the information preferences maintained by an app And in the case of Facebook, like text and photos, it's the stuff you want to save to your profile. This can be as simple as storing the user's zip code or as complex as storing large amounts of data such as thousands of pictures and songs. So how does it all work? All right, so talked about the user interface, right? So the UI enables the user to interact with the app and perform a task. The logic responds to what was pressed. And then data persists. Logic can persist the user's data, and that's governed by the user's choices. So now we're going to quickly move on types of apps. You've got 4 main types of applications. We've got a data-driven apps. Data-driven apps with apps that have a lot of dynamic data are either stored in a local database or retrieved from an external pool, right? Game apps. Both simple game apps like isometric games and games using 2D and 3D modeling of objects and characters. There's device apps, apps that aim to simplify and or improve some of the mobile device functions such as alarms, calendars, tasks, Instagram, Sleep Well, Alarm HD. Those are 2 apps that you can kind of look at. Custom functionality. Apps developed specifically for your client's custom requirements that have no off-the-shelf alternatives, right? So these are like completely custom apps. And then there's custom utility applications. And we're going to look at different examples here. So Facebook is completely data-driven, and these apps primarily allow the user to store and retrieve data. So you're going to store things. Facebook allows you to save and retrieve your data that you have stored in your status, photo albums, videos, etc. And then, of course, you have your game apps, and of course, many of you are all familiar with the Angry Birds game here. You have your device apps, so apps that aim to simplify and or improve upon the mobile device applications, that are already included with your phone. And then, of course, your custom functionality apps, your Tap to Do and Interview Assistant. So apps that provide a quick way to manage a list or any data that the user wants to persist or save. And then, of course, with the Interview Assistant, you're going to be doing things like inputting and storing and organizing content. And one more thing that I just want to bring up really quickly is native apps versus web apps. And many of you have probably heard or know about the difference, but we're going to be focusing on designing native apps for the phone, not web apps for the phone. So native runs straight from your device. These applications are usually coded using the device's operating system and is installed directly into the device's storage. Native apps are faster, and these apps take full range of the device hardware and sensors such as the camera, GPS, accelerometers to accomplish tasks. So the native apps can really tap into the hardware of the phone itself. Web apps, these apps are not installed on the device and have to run off of a web-hosted server. Because they are not directly installed on the device, these apps may not be able to take full advantage of the device's hardware. They are also limited by the capabilities of the device's browser and connection speed. So some examples include web versions of social networks and web-based email and cloud services. So we have the Facebook app here, and I have the native version on the left-hand side, and then the web version. So if you go into your phone and type facebook.com, that's what it'll look like on the right-hand side. That's a screenshot. So just a short review. Briefly went over the three different main parts of an application. You get the user interface, and this is generally speaking where we're going to be focusing in this course, is really on the user interface. The logic, not so much, and we're definitely not going to dive into any data persistence. And then just knowing the difference between native apps and web apps. And then in terms of the three projects that we're going to be working on, you're going to want to know or look at different examples if you're creating a data-driven app or a game app, a device app, or custom functionality and utility applications.
This lecture wraps up week 1. Next week, we will start looking at design patterns for both iOS and Android, as well as review Apple's Human Interface Guidelines, which also goes into detail about interface design. For those of you who will be designing for Android devices, I recommend looking through Chapter 5 to 13 in the Android Design Patterns textbook. For those students who will be designing for iOS devices, I recommend looking at the iOS website links I provided as part of the reading, as well as reviewing the Human Interface Guidelines. Lastly, assignment number 1 is due next week, Wednesday, the 18th. Please upload your completed assignment on Lalima. As always, if you have any questions, please feel free to email me. Aloha.